Let's talk about the basic data types of Python. So in our previous program where we learned about variables, we ended up with this code. And all the blue parts here are a data type called strings. And the way you tell a string is by the fact that it's surrounded by two quotation marks at the end. It doesn't matter if you use double quotes or single quotes. They are equal in value. So this is a string, and even the space here is part of the string. Basically, that's alphanumeric characters you can get from the keyboard, and they are treated as characters. They're not treated as numbers. If you want a number, you input a number and you just don't use the quotes. So that is now something called an integer. So an integer is a whole number, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course, sometimes we want to have, or most of the time, we might want to have decimal numbers, and those are called floats. So now I've turned this integer into a float, a floating point number. Another type of data that we have is something called a Boolean. And a Boolean is a data type that can take on the value true or false, only those two values. And we use those a lot in programming when we want to control how our program runs or when we want to check for different things. We don't use them that often in real life, but we use them a lot in programming. So an example in this case might be is going to party. Spelled correctly. There we go. Is going to party equals, now in the beginning of our story, that probably would have been false. At the end of our story, it probably would have been true, which was better for Eric, not so good for John, because he probably had false. Until Monday, at least, when his mother found out what actually happened, and Eric would be in real trouble. But that's a different story. So when we name variables, we obviously shouldn't do what I did there. It needs to be one word, and we use underscores between the words and don't use capitalization, at least in Python. And you can also use camel casing, which would be this type of writing, where you capitalize every new word. But the standard in Python is to use underscores between the words. So there we go. Now, I said that it doesn't matter if you use double quotes or single quotes, and that's correct. And then there are some cases when you get into trouble and don't know exactly what you're going to do and how to handle it. And here is an example of that. So let's say you have a variable where you want to store the word it's. So you write it's, and if you take a look at the code now, only the IT has turned blue. The S is white, and it shouldn't be, because we want all of it to be the string. But Python is not understanding us, and that's because this thing is being interpreted as the end of the string. So we need somehow to tell Python that it's not the end of the string, that it needs to use the quotes at the end as the actual end of the string. So the way we can do it here is to change this to double quotes, and at the end, double quotes. And now it's seen as a string, and it will be interpreted that way. There's another way to do it, which is called escaping. And there's an escape character in most programming languages, and it's the backslash. So if we were to do the same thing, so here, copy that. This time we want to use the single quotes. We don't want to change the double quotes. So it's now broken again. And by inserting a backslash, tells Python, the character I have after this, I want to actually use the literal character, nothing else. So this tells Python that after the backslash, I want to use the character that you see. Don't interpret it as something smart, just do what I tell you. So that's how escaping characters works. So when you're working with this, you sometimes want to know what data type you're dealing with. And there's a command for that called type. And you input whatever variable you have into it and you get an answer. So I'll show you an example right here. So here are 4 statements, and we'll get rid of these for the moment. Now if we run these, we'll find out what type we're dealing with. So we have a string, hello, we have a number, 1, we have another number, 1.64, and we have true. So how are those interpreted? Well, the first one is a string. The second one is an int or an integer. Next one is a float, and the last one is a Boolean. So now we'll go back to our previous program, paste that back in. Remember I said that you could use the numbers? Well, you can't mix numbers or different data types any way you want. There are some rules around how you can do that. So for instance, you can't put numbers. So if I make this a number, you can't put that inside the string, or you can't mix it with the strings. So the way to get around that is something called typecasting, or casting or changing a type. Basically, you're telling the type. So in this case, it's an integer. I'm telling the integer, hey, integer, I don't want you to be an integer anymore. I want you to be a string. And the way you do that is by using the shorthand, str, and you encapsulate this like that. And we do the same thing down here. Now, it will use the actual number. So let's run that. Now, if I don't have this casting, if we remove this, it fails. It actually says it can't convert int to string implicitly, so I have to do it explicitly. String to change the integer to a string. And the same thing would happen if I put this like that. So that was a run through of data types and typecasting, and I'll leave you with a few examples. So here, if we cast 1 into an integer, we will get 1. If we cast 2.5 into an integer, we'll get 2, so it removes the decimal. If we cast the string 3 into a decimal, we'll get 3. And here's a special case. If we cast 3.4, the decimal in string format, into an int, it's actually going to return an error. So we'll come back to that a bit later. And if we cast 1 into a float, we'll get a decimal number, so 1.0. 2.5 into a float, 2.5. 3 as a string into a float becomes 3.0. And 4.23 into a float becomes 4.23. So that's the case we had up here, but here it works. Then if we cast 80s, the string, into a string, we of course get the same thing. 22 into a string, we get 22 as a string, so it's no longer a number. 3.01 becomes the string. 3.01, again, it's no longer a number. So let's try and run these and see if the results work. And they do. So now let's go back to the one we had up here. So it turns out that you can't actually do this. If we run it, error. And the reason is, this is a decimal string, and we're turning it into an integer, and that's not an allowed operation. You can do it with a float, as we did down here. So what you can do to handle this is to first cast it into a float, and then cast it into an integer. And then we add the variable, C1, and we see that we get another 3. So I hope you enjoyed that, and I'll see you next time.